There you go. 9.6, like I said, was solving equations. So we'll be solving exponential equations first. And about my first 9 problems will deal with exponential equations. Then we'll look at solving logarithmic equations. And the last 8 questions are dealing with that, okay? So here we go. Let's go with solving exponential equations. So y'all, exponential equations are when the variable is the exponent, okay? So first thing we try to do, if possible, is rewrite each side of the equation using the same base. So if possible, rewrite one or both sides of the equation using the same base. So what happens if I can get each side of the equation written with the same base? I can invoke what we call the base exponent property. Now, this base exponent property tells me if a to the x equals a to the y. So you got 2 sides equal and they got the same base. If that happens, that means the exponents must be equal. So then x equals y. Okay, so that's only if it's possible for me to rewrite it. Now, if it's not possible to rewrite each side using the same base, now, if it's not possible for me to rewrite each side using the same base, then I got to take another course of action. So the first thing I would do at that point is take a log or a ln of both sides. And that just goes back to what I do on one side, I do to the other side of that equation. So I'll either take a log or ln. Now, I'll usually do a log unless there's an e in the problem. If it has that little e, then I'm going to use an ln, because remember, ln's are log base e, okay? All right, so I'm going to take a log or an ln of both sides. Then, using the power rule, I'm going to bring those exponents down to the front and rewrite as a product. So bring the exponents down. And rewrite as a product. Okay, so then, whether I've rewritten it using the same base or I had to take logs of each side, after that, we will then solve for the variable. and then check answers if needed. Hey, y'all, so that's the steps I'm going to be following. So let's start solving some equations. So these will just say solve for x. Okay, so I'm going to start with number 1. I got 6 to the x equals 36. So the first thing, if possible, rewrite this equation so it's got the same base on each side. So I got a 6 to the x over here. So I'm looking at this number 36. And I'm wondering if I can rewrite 36 using a 6 raised to an exponent. So on this one, I actually can. So what I'm going to do, I'm going to rewrite 36 as 6 squared. So that's what I'm talking about, writing the same base. Okay, I had a 6 over here. So I wanted to rewrite my 36 using a 6 if I could. You know, 6 times 6 is 36. So I'm going to write that as 6 squared. So putting that in, I now have 6x equals 6 squared. So notice, I can invoke the base exponent property because my bases match. And since these bases match, that means the exponents have to be equal, which means x has to equal 2. All right, y'all, to check that out, put my 2 in for the x. 6 squared is 36, and 36 equals 36. So that is definitely true. All right, another one that's similar to that. 4 to the 5x equals 16. So I got a 4 for the base over here. So I'm wondering if I can rewrite 16 using a 4 as the base. And y'all, on this one, we can actually do that also. We can rewrite 16. Well, 16 is what? 4 times 4? So I can rewrite 16 as 4 squared. So that gives me 4 to the 5x equals 4 squared. All right, notice this. I now have bases that match on each side. So since these bases match up, that means my exponents have to be equal. So this 5x has to equal that 2. All right, so on this one, we actually got to solve it now. So to make that a 1x over here, I will divide both sides by 5. So that cancels, giving me my x equals 2/5. So if you plug the 2/5 in here, the 5's cancel, and 4 squared is 16, and 16 equals 16. So they're not too bad if we can get these bases rewritten. But y'all, sometimes you hit something like this. 5 to the x equals 24. So guess what? I cannot rewrite 24 using a 5. So I'm not going to be able to do step 1. So that means I got to go to step 2 that says if it's not possible to rewrite each side, I'm going to take a log of both sides. So I'm going to take a log of both sides. So I have log of 5 to the x equals log of 24. And I'll tell you the truth, the whole reason we're taking logs is so I can bring this exponent down to the front using the power rule. Without taking logs, I wouldn't be able to do that, okay? So I want to bring that exponent down to the front and write this left side as a product. So that'll be x times log 5 equals log of 24. Now that x has been brought down to where I can now solve it. So what's happening here, since the x is being multiplied by the log 5, we're going to divide both sides by log 5. So I'll have an x log 5 divided by log 5. That's going to equal our log 24 divided by our log 5. So these logs cancel. That gives me my x. Now these are logs. So when your answer involves logs at the end like this, we're going to get a decimal and we're going to have to estimate it 4 decimal places. Now, y'all, it's really important on the calculator that you close those parentheses on those logs, okay? So I'm going to go to the calculator and show you how I would actually do this one. Now, I make it look like a fraction, so I always hit alpha y equals and enter. So I get that fraction bar up there. And then I had log of 24. So we want to shut that parentheses and then arrow down on bottom, and we had a log of 5. And then close those parentheses. So now it looks just like I had it on my paper. So I'm going to hit enter. And then I'm going to round this 4 decimal places. So that means 4 numbers after the decimal. So this will be 1.9746. So the 6 will stay a 6 since it had a 3 after it. So y'all, 1.9746. Okay, so you gotta estimate the answers out to those 4 decimal places, okay? All right, y'all, number 4, 3 to the 9x minus 5 equals 81. So I got a base 3 over here. I'm wondering if I can rewrite 81 using a 3 as the base. And y'all, that'd probably be yes, because I know 9 times 9 is 81. And each of them 9s is 3 times 3. So that's giving me 4 3s to equal 81. So I'm going to rewrite 81 as 3 to the 4th. So I get 3 to the 9x minus 5 equals 3 to the 4th. All right, my bases match. So that means the exponents have to be equal. So 9x minus 5 has to equal 4. So y'all, I don't think these are too bad when you can rewrite them with the same base. When you can't rewrite them with the same base, they're just a little trickier because you got all this log going on, okay? So we're going to solve this and see what this x has to equal. So y'all here, I'm going to add 5 to both sides. I get 9x equals 9. And then I'm going to divide both sides by 9. And y'all look at that. Those cancel, giving me a 1x equals, well, 9 divided by 9 is 1. So if you put a 1 in here, 9 times 1 is 9. 9 minus 5 is 4. And 3 to the 4th equals 81. Okay. All right, y'all. So it's just a matter of either rewriting them with the same base or taking the logs. So here we go. 3 to the x equals 5. Well, guess what? You can't rewrite a 5 using a 3 as the base. So that means we got to take the logs of each side. So you got a log 3 to the x equals log 5. Ooh, excuse me. Okay, y'all. Power rule, bring that x down to the front. So that'll give us the x times log 3 equal to a log 5. You know, the same thing when I had my x log 5 here, I divided both sides by log 5. Here I got an x log 3, so we're going to divide both sides by the log 3. So these logs cancel, giving me my x like I wanted. This, we're going to have to estimate 4 decimal places. So on this one, it rounded off to a 1.4650. Okay, so you just got to watch out for what's happening in the beginning. Are you rewriting it or are you having to take a log, okay? Let's let y'all get that caught up and then we'll flip the page. Hey, also, number 6 is one of the trickier ones. I got 10 to the negative x equals 8 to the 5x. So I've got the variable on both sides of this equation. Now, I cannot rewrite this 10 and 8 using the same base. So that means right off the bat, we're going to take a log of each side so we can get them exponents brought down. So we'll do our log of 10 to the negative x. That's going to equal our log of 8 to the 5x. All right, so we did that so that we could bring our exponents on each side down to the front. So all you get negative x log 10 over here. That's going to equal a 5x log 8 on the right side. Now, I will say this. There's only one exponent that I can technically put in for each of these that'll make these two things equal. And y'all watch when we're done. It's going to sort of be an obvious exponent when we're done. So now I got an x over here, and I got an x over here. So what I need to do is get all these x's on the same side. So since this is one big term, to get all my x's on the same side, I'm actually going to add the x log 10 to both sides. So this side, the negative x log 10, positive x log 10, they add up to get me a 0. Now, these are not like terms, so I'm just going to write this as 5x log 8 plus my x log 10. So here's an interesting situation because here's the X and here's the X. So I'm looking for a way that I can take these two X's and turn them into just one X. And y'all, the way you're going to do that on this one, you're going to factor out the greatest common factor. So bring that 0 down. So the biggest common factor of these two terms is the X. The X is the only thing they got in common. So we're going to factor out that X. So y'all just remember that in the future. When you got an X in two different terms and you need to make that into one X, you're going to factor it out as a GCF, okay? So what's going to go into parentheses is the 5 log 8 plus the log 10. Okay, so that's the only way you can bring out an X when you got two terms that are not like, okay? So now this X is being multiplied by 5 log 8 log 10. I'm going to divide both sides by 5 log 8 log 10. So my 0 will be divided by 5 log 8 plus log 10. That's going to equal the right side. Divided by the 5 log 8 plus log 10. On the right side, those are going to cancel, leaving me my X. And y'all look at that. 0 divided by anything is 0. So to answer my question, Walgo, the only exponent that I can put behind that 10 and that 8 to make them sides equal is a 0. Because 10 to the 0 is 1. 8 to the 0 is 1. So remember, anything to the 0 power equals 1. So when you got these different bases like that, look for these kind of answers, okay? So that is sort of tricky because you had to do that greatest common factor stuff on it, okay? All right, y'all. So this next problem is one where I would do a ln versus a log. I've got e to the t equals 153. So I'm not going to try to rewrite that using the same base. So I'm going to jump right off to take a ln instead of a log. I'm going to do an ln, and you'll see why in just a second. So I'm going to take an ln of e to the t. That's going to equal an ln of 153. So let me go back to a little property we learned last week. We said if we had an ln of e to an exponent, this simplified down to just an x. This, because ln of e, remember, that's like a log base e of e. That part equals 1. So when you bring that exponent down, you have x times 1, which is just x. So over here, when I bring that exponent down, that's going to be like t times 1. So y'all, the left side is just going to equal t. So that's why I really like the ln of the e stuff. Better than the logs, okay? Now, I got the left side. The right side is going to be ln of 153. So y'all, all we got to do is punch in the ln of 153 and see what we get. And that's going to give us a 5.0304. All right, so I got another one dealing with the E to get you in the shape of those. So let's try this number 8. E to the negative 0.87 t is going to equal 0.89. So y'all, that's the E over here again. So I'm going to take an ln of both sides. ln E to the negative 0.87 t is going to equal the ln of 0.89. Well, we're going to follow the same pattern up here. ln of e to an exponent equals the exponent. Well, I got ln of e to an exponent. So the left side's just going to equal the exponent. Now the right side, I can't do nothing at the moment. So that's going to stay ln 0.89. Now, y'all, the difference on this problem and this one, I still got to deal with this negative 0.87 being multiplied by my t. So we're going to divide both sides by the negative 0.87. And that'll equal my ln of 0.89 divided by that negative 0.87. Now this one, remember, shut those parentheses around that ln when you punch it in that calculator. So y'all, let me go punch this one on the calculator real quick. So I'm gonna make it look like a fraction. So alpha y equals and enter. So on top I had an ln. So the ln is right here by the 4. 0.89. Close parentheses. And then on the bottom I had a negative 0.87. So y'all hitting enter, we will get our, what's that, a point? So that is a t is approximately 0.133. Let's see, the 9 has a 4. So the 9 will stay a 9. So that'll be 0.1339. So rewriting them is the easiest way if I can rewrite them using the same basis. If I don't have an E, I take a log and I end up having to approximate my answers if needed. If I do have the E's, I take LNs because those are the quickest way to do the problems with the E's on them, okay? All right, so the last one is going to be exponential, has a 6x equal to a 3 to the x plus 1.
Hey, Mr. Rathon, I didn't hear you. Why is number 8? Why is it 0.1339 and not 0.1340?
Because let's go back to my calculator here. So I'm looking at the 4th spot, which is where the 9 is. So to determine what I do to that 9, I'm looking at the next number, which is the 4 following it.
Okay, I wasn't listening to what spot we was rounding to. Okay.
Yeah. Now, if that 4 would have been a 5, 6, 7, 8, or 9, I would have rounded that up.
Okay.
Okay. Now, y'all, this one's going to be the most tedious one, I think, is this number 9, because it's the last one of the exponentials. But I cannot rewrite these using 3s or 6s. So since I cannot rewrite them, I'm going to take a log of both sides. So we'll have the log of 6 to the x equals log of 3 to the x plus 1. All right, so we did that so we could bring our exponents down to the front. So the left side, I get my x times log 6. But y'all, guess what? On the right side, there's 2 parts to this exponent. So what I need to do is write that x plus 1 in parentheses and then make that a product with the log 3. Because both parts of this exponent got to be multiplied by that log 3, okay? So what I'm going to do, my next step is get rid of these parentheses. So the left side is going to stay at x log 6. Now over here, you got 2 things times 1. So both of these get multiplied by log 3. So the x times log 3 is a x log 3 plus 1 times log 3 is a log 3. So be careful if you got 2 parts to the exponent. Remember, both parts have to get multiplied by that log 3. So now we're looking at this. We're solving this for x's, remember? But I got an x on the left side and I got an x on the right side. I want all my x's on the left side. So we're going to subtract the x log 3 from both sides. So let's see what that does over here. That's just going to give me what? An x log 6 minus the x log 3. Over here, the log 3 x's cancel. So all that's left is this log 3. So y'all, let's see what y'all think about this. I got 2 terms over here that's got these x's in them. Now, hopefully I can make both of them x's into 1x. So do y'all remember what I can do right there to make them 2 x's into 1x? All right, so I'm going to
Pull
chance
the x out. Factor out the x.
factor out the x. There you go. Perfect. So I'm going to factor out the x's. So that's going to give me an x. So here, let me write that. Factor out the GCF. All right, so that x will come out. That's going to leave you a log 6 minus a log 3, all equal to our log 3. All right, so now we're to the point I got an x times this log 6 minus log 3. So if I want that to be a 1x, we will divide both sides by the log 6 minus log 3. And that's what gets sort of tricky on these is you got such big things you're dividing by, okay? So I'm going to divide by that log 6 minus log 3. So over here, that'll equal my log 3 divided by the log 6 minus log 3. So y'all, these cancel, leaving our x. Now this one's tricky. I would definitely make this one look like a fraction on my calculator. So y'all, let's see. Let's go to calculator. So I would hit my green alpha button and my y equals and hit enter to get that fraction. So on top, not too bad. It was just a log 3. So put in my log 3, close my parentheses. Now go to the bottom. That was a log 6. So log 6, close those parentheses, minus log 3, close those parentheses. So y'all, it now looks like what we needed. So now let's round this off to 4 decimal places. So that'll be a 1 point. Oh, now guess what on this one? I got a 58496. So what are y'all rounding that one off to? So definitely the 4 is going to become a 5, which means the 9 is going to become a 0. So that 496 is actually going to make that a 50. So we're going to get a 1.5850 on this one. Okay, so since the 9 had a 6 after it, we did have to sort of round everybody up. But y'all, let me show y'all a trick. If you're weak at rounding off 4 decimal places, watch what I do. You see this mode button right here? I'm going to hit mode. And I'm going to arrow down to where it says float. Float, that does the decimal places. So I had to do 4 decimal places. So watch this. I'm going to go over here and put my cursor on a 4 and hit enter. So now 4 is highlighted. Y'all watch this. Since the 4 is highlighted, it's going to round all my answers 4 decimal places. So y'all watch this when I hit enter. 1.5850. So if you want your calculator to round you off to 4 decimal places, hit mode and come down here where it says float and put that cursor on 4. Now, if you want to put it back, you have to switch it back to float to get it back to normal, okay? So to go back to normal, I'd hit float and enter. But if you want to round 4 decimal places, put that cursor on 4 and it'll do it for you, okay? All righty, y'all. So that brings us to our logarithmic equations. Now, the logarithmic equations, we don't really have to round any decimals on them, okay? That was mainly just your exponential equations. So these ones, like I said, will be solving logarithmic equations. So logarithmic equations are like y equals log base a of my x. Okay. We're pretty much going to be solving for the x when it's these results here with my variable. Now, since we're doing a logarithmic equations, all those properties we did last Thursday, those properties of logarithms, they're all in play. Remember, I can rewrite products as sums and sums as products. I can rewrite quotients as differences and differences as quotients. Okay, so all them little properties are going to be in play. So the first thing you got to do, if needed, combine logs on either side of the equation. So what I mean by that, we're going to write them as a single log. So if you got two logs on one side, you got to turn them into a single log like we did on those exercises. All right, next. I look at both sides and I look and I see if I have a log base on each side. So do we have a log base equal to a log base? Sort of similar to the base exponents we were looking at when I could rewrite each side using the same base. Well, here, do I got a log base on the left side equal to a log base on the right side? If I do, I can invoke what we call logarithmic equality. So let's see, logarithmic equality tells me that if I got a log base m equal to a log base n, so notice I got a log with a base a equal to a log with a base a. If these bases match these logs, then y'all, that means m has to equal n. Okay, and that's because these two sides are set equal to each other. Then by deduction, those two have to be equal, okay? Now, if not, so if it's not a log base equal to a log base, then I got to go to another step. I'm going to rewrite this as exponential. So then rewrite as exponential. So that's why we had to do those exercises where y'all turned the logs into exponential, and then you had some where you did the exponential and turned them into logs. All right, once I've rewritten it as exponential, I'm then going to solve for the variable. And then check those answers if needed. Now, you don't have to check answers every time if you're confident, but I will say this. There's a certain type of answer that I cannot take when I do these logs. So do y'all remember when we was doing 9.4 and y'all were doing all those logs on the calculator? There was one type of number that y'all put in and y'all got error messages on it. And it said error, answer non-real and stuff like that. What kind of numbers were we putting in on those? So y'all, let me bring my calculator up. And y'all watch this. I'm going to do a log. And I'm going to put a negative 36 in there. Can I take the log of that negative number? And y'all watch what happens. Error, non-real answer. Because remember, we cannot turn a 10 into a negative number. There's no way to use that to do that with an exponent. So if we get negative answers on a log equation, we got to throw them answers away. So we cannot take answers that are negative. So in the ones where this happens, you'll get one positive answer, one negative. Well, you're going to throw that negative answer away and only keep those positive answers, okay? Hey, y'all, so here we go. We're going to now solve for x. So they'll start out where I rewrite them as exponential, and then they'll throw some of these in where I combine logs, and then some of these where I have the log equal to the log stuff, okay? So they start out a little minor. So I'm going to start out with a log base 4 of x equals 2. So I don't got but one log, so I can't combine logs on either side. I don't have a log equal to a log. So I'm down to this step that says rewrite as exponential. So we had problems where we had to rewrite this stuff. So the base is the 4. The exponent is the 2. And that's going to equal a result of a x. Hey, y'all, so the only step I got to do is figure out what 4 times 4 is. So 4 squared is 4 times 4. So that gives me 16 equal to my x, and we're done. So some of these won't be bad. Now, they're going to throw more work at us. Like this number 11. I got a log of x equals negative 5. So this one I'm going to rewrite as exponential. So let me write that under here, what we're doing. So I'm going to rewrite this one as exponential. Oh, but y'all, there's not a base here. What's the base of this logarithm if there's not a number here? All right, now let me catch my chat up. Y'all are saying 10, good job. So that'll be a 10 exponent negative 5. That's going to equal x. So now we're pretty much done, but MathLab wants this as a decimal answer. So what this negative 5 means, if you had a 1 sitting here, and the decimal would be after the 1, since that's a negative 5, to write this in decimal form, you have to move left 5 spots. So that means you'd have to add 4 zeros on this one. Okay? And that's going to equal your x. So I end up with a 0.00001 equal to my x. Okay? If you had a negative 6, you would start on the right side of the 1 and move left 6 units. Okay? Yeah, so that's what I'm saying. So the calculator, so let me show you what that means on the calculator. You got 1e negative 5. So this is putting it in what we call scientific notation. And this e basically means times 10. So when you see something like this, this means 1 times 10 to the negative 5th. So that's all this e means, is it's sort of shorthand for that times 10 part, okay? Which basically 1 times 10 to the negative 5th is giving us back this. And MathLab's sort of picky, and it wants it written as these decimals on them, okay? But yeah, when y'all do them science classes like chemistry and stuff, y'all will probably mess with doing that scientific notation in there, okay? All righty, also pulling that down. So number 12, I got a log base 6 of 4x minus 4 That's going to equal 4. So this one I'm going to rewrite. So our base is a 6. Exponents to 4. And 6 to the 4th is going to equal that 4x minus 4. All right, so we will figure out what 6 times 6 times 6 times 6 is. Ooh, 4 6s give me 1,296. That's going to equal my 4x minus 4. And y'all, to solve this, we're going to add 4. Ooh, that's what, 1,300 equals 4x. And then divide both sides by 4 to make that a 1x. So y'all figure out what is that 1,300 divided by that 4 going to give us. Let's see, what is that? 325. Yep, that sounds good. Okay. So y'all, that's the tricks is remember, base, exponent, result. Okay. So 13, they're going to start changing it up a little bit. So watch what I got here. I got a log x plus a log x minus 21 equals 2. Well, look here. I got 2 logs on the left side. And we said, if needed, we got to combine logs on either side. Well, since you got 2 logs on the left side, we need to write these as a single log. So remember, these are being added. So when we write a sum of logs as a single log, we write it as a product. So this log will come out, and then the x will be multiplied by the x minus 21. All of that is going to equal 2. So this was the homework y'all did last Thursday when you had to write 2 logs as a single log. Now, I'm going to go one step further and actually multiply this stuff. Well, I'm going to bring down my log. So we got an x times x will give us an x squared. X times negative 21 gives me a negative 21x. All this equal to 2. So now we've got it rewritten as a log, a single log. At this point, we're going to rewrite this as exponential. All right, so guess what? There's not a base here again. So we know that that base is a 10. So my base is a 10. My exponent is a 2. And that's going to equal that result, which is a x squared minus 21x. So y'all, we're going to end up with a quadratic equation on this one because we got an x squared. So that means we're going to have to get everything on one side equal to 0. But before we do that, that 10 squared, we're going to turn that into 100. 10 times 10 is 100. And that's going to equal my x squared minus 21x. All right, y'all, so let's get a 0 over here. So we'll subtract 100 from both sides. So notice, you now get a 0 equals x squared minus 21x minus 100. Alrighty, so I'm not going to break out no quadratic formulas or anything. I'm going to solve this by factoring. So I got an x and an x. Now, let me tell you what. On these problems, when you're doing these log equations, one factor will always be positive. One factor will always be negative. Because that last number is always going to be negative, okay? So you're going to have unlike signs. But y'all, what I really need are the factors of 100. That'll give me 21 and, ooh, y'all got it, 25 and 4, perfect. So the 25 is negative like the middle, and the 4 will be positive. All right, now set both these equal to 0 and get my answers. So I'm going to subtract 4. I get x is a negative 4. I'm going to add 25. And I get x is 25. So what's my final answer? And I'm going to go up to here and say one thing. I cannot take answers that are negative. Because if you try to take a log of a negative 4 when you check that, you're going to get an error. So we're going to cancel out that negative answer. And the only answer to this is x equals 25. So remember, throw away those negative answers, okay? All right, y'all, I'm going to let y'all catch up on that one, and then we will hit the next one. All right, y'all. So let's see. Let's see, I'm on what, number 14, okay. Now y'all watch this one. This is pretty wild looking. I got a log base 3 of t plus 16 minus a log base 3 of t plus 7. That's going to equal a log base 3 of a t. Y'all, we got logs all over the place on this one. But the first thing we got to do is on this left side, we got more than one log. So on the left side, we got to rewrite that as a single log. But y'all look here. These logs are being subtracted. So since they're being subtracted, we're going to rewrite those as a quotient. So we bring out our log 3. Because remember, all the stuff that was always subtracted went to the bottom of those fractions. So we'll have our t plus 16 on top. Then the t plus 7 goes to the bottom. And that's going to equal the right side, which is a log base 3 of a t. So look at this. I got a log base on the left side equal to a log base on the right side. That means since I got a log base equal to a log base, that means this result equals that result. So this t plus 16 over t plus 7 equals that t on the right side. Okay. Now, to solve this, I'm going to make the t look like a fraction and put a 1 under it. Now, this is what the support for 9/6 will have you doing. To solve this for the t, I'm going to cross multiply this. So, y'all, I'm going to use this property right here. If A over B equals C over D, then A times D equals B times C. So we cross multiply to get rid of these fractions. The top of one fraction times the bottom of the other one, the bottom of the first fraction times the top of the second. So I'm going to take this t plus 16 and multiply by 1. So I get 1 times t plus 16. That's going to equal this bottom times that top. So that'll be t times t plus 7. So you got 3 problems in support doing this cross multiplying. And then the last 2 we're just working on factoring, okay? All right, but notice I got rid of the fraction. So now distribute the 1 over here. Well, 1 times t is t plus 1 times 16 is 16. Over here, distribute the t. T times t is t squared plus t times 7 is 7t. So the t multiplied by 1, the 16 multiplied by the 1. This t multiplied by that t giving me t squared. This 7 multiplied by that t giving me 7t. Now, I got a t squared term and a t term. So I need everything on one side equal to 0. So to make this side a 0, I'm going to start by subtracting t from both sides. And then I'm going to subtract that 16 from both sides. So look what's happening. Everything cancels on the left side, giving you a 0. Now, bring down the t squared. 7t minus 1t leaves me 6t. And then at the end, there's no like terms, so just bring down that negative 16. Oh, look, we get to factor again. And if you notice, the last number's negative again. So that'll give me a t plus and a t minus. So what factors of 16 can I get a 6 out of? 8 and 2. So let's see. This time the 8 is going to be positive and the 2 negative. And just notice I'm always making a larger number the same as the middle. All right, so you got me factored. So let's set both them equal to 0. And solve by subtracting 8 on the first one. Adding 2 on the second one. So, final answer. All right, y'all remember, kick out that negative answer. Cannot keep a negative answer. So good job. T is definitely 2 on that one, okay? So if you notice, the worst part of these is having to get the equation set up so you can actually factor them to get them answers. All right, let's look at this 15. I got a log base 4 of x plus 1 minus log base 4 of x. All of that equals a 3. So 2 logs on the left side, no logs on the right side, because I'm not going to be able to do that log base like I did here. But I do got to start out rewriting those as a single log. Now notice they're being subtracted again, so it's going to look like a quotient like this one did. So bring out that log 4. Top will be the x plus 1. The bottom will be the x. And all that's going to equal that 3 on the right side. But y'all, if you notice on this one, I don't have a log base over here, so I can't set x plus 1 over x equal to the 3. But since I got a single log equal to a number, I got to rewrite this as exponential. So my base is the 4. Exponent is the 3. And that's going to equal the x plus 1 over x. So y'all, what is 4 to the third? That'd be what? 4 times 4 times 4. So let's see, 4 times 4 times 4 is going to give us what? Oh, somewhere you, let's see, 4 times 4 is 16. 16 times 4 is going to give me 64. There you go. So 64 will equal x plus 1 over x. So guess what? Since I got a fraction over here, I'm going to make the 64 look like a fraction by putting a 1 under it. And then I'm going to cross multiply. So I got 64 multiplies by the x. So that'll give me 64x. The other side, I got 1 times the x plus 1. Well, 1 times anything is the anything. All right, y'all, so I did 64 times x on the left side. 1 times x was x. 1 times 1 was 1. So solving this, your first step is to get all the x's over here. So let's subtract the x from both sides. So I get my 63 x's equals 1. All right, well, I want that 63x to be 1x. So let me divide both sides by 63. So notice those cancel, giving me my x. Oh, y'all, I can't divide that, so nothing I can do to that. So I'm going to leave that a 1 over 63. All right, so what makes the log ones a little tricky is how you got to solve these things. Do I got a factor over here? Do I got to cross multiply to get rid of stuff? And remember, some of them you had to cross multiply then factor. So they get a little tricky at times. Oh, yeah, so I got 2 more to go. Let's try 16. Okay, 16 is pretty big. It's got a log 3 of x plus a log 3 x minus 1. That's going to equal a log 3 of a 6. So look here, I got logs everywhere. I got logs on both sides. So eventually, I'm hoping to get this to a log base equals a log base over here. So the first thing, rewrite that left side as a single log. Now remember, these are being added, so we rewrite this as a product. So bring out that log 3. And my product will be the x times the x minus 1. All that is going to equal the right side, which is a log 3 of a 6. And y'all, let's go on and multiply this out. So bring down that log 3. X times x is an x squared. X times -1 is a negative x. All that equals log 3 of 6. So we're sort of happy on this one. This log base matches that log base on the right side. So since the log bases match, that means that the x squared minus x has to equal that 6. And if y'all notice again, this one's quadratic again. So the 6 is where I need a 0 at. So let's see, to make that a 0, we're going to subtract 6 from both sides. So no like terms. So that's just going to give me an x squared minus the x minus 6, all equal to 0. Now remember, that's negative again. So when we factor this one, we're going to have unlike signs again. So y'all, what factors of a 6 equal a 1?
Three and two.
3 and 2. So let's see, the 3 has to be negative and a 2 positive. All right, so let's just set them equal to 0 to get our answers. And y'all, by now you're seeing that all I'm doing is changing the signs on these things. So that x is a -2, and over here, x is a +3. And guess what? I cannot keep that negative answer there. So the only answer, x equals +3. All right, y'all, so we got one more to go. Log 3, x plus 12, plus log 3, x minus 12. All of that equals a 4. All right, so look here, once again, left side, I got to rewrite as a single log. And I'm noticing these are being added. So since they're being added just like that one, I'm going to write it as a product. So I'll bring down my log 3. My product will be the x plus 12 times the x minus 12. All of that is going to equal 4. And y'all, let's multiply this stuff out real quick. Now, let me tell you something. These are conjugate pairs, so I can shortcut FOIL conjugate pairs, remember. I can do the x times x. That'll give me an x squared. And then I can do the 12 times -12, which is a -144. All that equal to my 4. So remember, conjugate pairs, the 12x and the -12x are going to cancel anyway. So just shortcut that stuff. Now, I got a log on one side, but not a log on the other. So I can't use the log base property like I did here, but I can rewrite it as exponential. So yeah, at this point, you either got two choices, logs on both sides to where you put the results equal to each other. Or if you got a log just on one side, you got no choice but to rewrite it as exponential. So I got a base of 3 raised to the 4th. That's going to equal that x squared minus 144. All right, so let's think. 3 times 3 times 3 times 3 is 81. That's going to equal x squared minus 144. Now, what's nice on this one? You got 2 choices. You can make a 0 on this side and factor it like it was perfect squares. Or, since you don't have an x term, you can add 144 to both sides and take square roots. I mean, you can do it either way. So remember, I can do it different because it ain't got these x's in the middle like we had over here. So y'all, let's see. Square roots are usually quicker. So 81 and 144 give me 225 equal to my x squared. So y'all figure out what is the square root of that 225. And guess what? I don't even care about a negative answer on this one because I can't keep the negative answer anyway. So just give me what the positive square root of 225 is, and we'll be done. Oh, y'all going slow today. Let me pull my calculator out for you. Remember, square root sitting right on front of that thing. So blue second, hit x2, gives you a square root, put in that 225. And guess what? When I hit enter, I get 15. So the square root of 225 is 15. Remember, I don't care about the negative answer on this one. I'm only concerned with the positive answer. Now, the other way you could have done it, you could have had 81 equals x squared minus 144. You could have pulled the 81 over and made this a 0. So 0 would equal x squared minus 225. And then that's where you would have factored that into conjugate pairs. You did an x and an x, plus and minus. Square root of 225 would still be 15. So you'd have factored it into conjugate pairs and then set each of them equal to 0. And you'd have still thrown out the negative answer, okay? So either way, you'll get that 15. If you like factoring better, do it like this. If you like doing square roots, move that number over and then square root it. All righty, so y'all let me give y'all the breakdown. So Thursday, 9.7. Whoops. Thursday will be 9.7, and it probably won't take us 30 to 40 minutes. Then next Tuesday, not next Tuesday because y'all going to be getting ready for Thanksgiving, but Tuesday, I think when we come back, let's see, that'll be the 28th. So on 11/28, we're going to review test 4. And it'll be open, and you'll have till that next Sunday. Now, I got the review open now for you if you want to play with it next week during Thanksgiving. So we do that Tuesday. The Thursday will be like the 30th, I think. Yeah. On that Thursday, we come back the 30th. We're going to start final exam review. And then Tuesday, Tuesday, December 5th is our last class period, and I'll do more final exam review if needed. So notice, after Thanksgiving break, all we got is a lot of reviewing to go. So we'll review for Tuesday on the test 4. That test will be open and due Sunday. And then we'll start reviewing for the final exam that Thursday. The finals open. The final exam is going to open on 12/6 on a Wednesday. That final will open on Wednesday, 12/6, and it'll be due Sunday, December 10th by midnight, okay? Yeah, can y'all believe it's already been what well, we're in week 14 now out of 16. So one more class period to learn college algebra, and that'll be Thursday. After that, it's just a lot of review, y'all. So let me stop my share here.